Hi everyone, welcome back to MediZ Academia. So please don't forget to like our videos, share and subscribe. So today we'll be talking about electrolysis. The discussion is based on electrolysis. The calculation aspect, in case if you need all those explanation terms, definitions, all those, then you can kindly subscribe to our channel so that you can have an access to the material we are using. So I'm only going to base only on calculation involving electrolysis using the Faraday first law and Faraday second law. Electrolysis. We know electrolysis is the chemical decomposition of a compound. It decomposes either by its melting forms. So here, under that one, we have two laws that we need to talk about. Faraday first law of electrolysis. Faraday's first law of electrolysis. And we also have Faraday's second law of electrolysis. So we do the two thoroughly so that if there's any electrolysis. So if there's any errors, you'll be able to, if there's any problem, you'll be able to figure it out. So Faraday's first law of electrolysis stated that the mass of a substance liberated during an electrolysis is directly proportional to the quantity of charges passing through the electrolyte. What does that mean? That is, the mass of a substance liberated during an electrolysis is directly proportional to the quantity of charges passing through the electrolyte. In physics, when we have current, current is a rate of moving charges, right? So if I make the Q as the subject here, I can have Q to be equal to IT. So Q that we have is the quantity of charges, I is what? Is the current, and T is the time taken. So the mass of a substance liberated during an electrolysis is directly proportional to the quantity of charges passing through the electrolyte. So in some materials, they can use the sign of quantity to be Z, while some they can use E. Any of the two that they use is still the same thing, just like the constant there. If I use Z, that means I can have M is equal to ZQ. So we have this Z, we call it electrochemical equivalent. Electrochemical equivalent. So that's the meaning of that Z. Z is called electrochemical equivalent. So M is equal to ZQ. Now, in doing that, I can, I can make a simple substitutions. So we have Q. Now recall from here, Q is equal to IT, current times time. If I substitute the value here, that means that we have M is equal to Z I T. So if I make my Z as the subject, divide all through by IT, divide all through by IT. So if this cancel this, I can have Z to be equal to M over IT. So I can even derive the unit for Z. Mass is gram, current is ampere, and time is second. So that's going to be gram per ampere per second. So it depends on the one you have to calculate. That's just about the first law. So if you are given, for example, maybe you have to solve a problem, you just make the one you asked to find as the what? As the subject of the formula. You will be asked to find either the electrochemical equivalent, or to find the mass, or to find the current, or to find the time. Let's see like one example there, then we can move further. So for example, let's say I have a question like this. Let's say I was giving data like, let me said mass is 200 gram, and we are given current to be 2.5 ampere. We are given time to be 1 hour, and we are asked to find electrochemical equivalent. So another thing you have to take note of in this case is that if you are given time, if the time is not in seconds, you have to convert that time either from minutes to seconds, or either from hours to seconds. So you can see the value of the time we have here is hours, so I have to convert that one to seconds, and we know 60 seconds make what? Make 1 instance. 3,600 seconds makes 1 hour. So like from here now, since I have 1 hour, I can see this is nothing but 1 times 3,600. So what we have here is 3,600 seconds, because if you are given time to be in minutes or hours, you have to convert that time to seconds. So from the formula we have here, we said M is equal to Z I T. So since I'm looking for the electrochemical equivalent, I can make it as the subject, divide all through by high T, right? Divide all through by high T. So if this cancel this, we have Z is equal to, our mass that we have is 200 divided by the current that we have is 2.5, and we are given time to be 3,600. So here we can have this one to be 200 divided by, so 2.5 multiplied by 3,600, we have it to be 9,000. So here we have 9,000. So 200 divided by 9,000. So what I have here is 0.022. So just like the unit we have the gram per ampere per second. So it depends on the one you have to calculate. You just make the one you have to calculate as a subject of the formula. If you have to find, let's say we have to find current, for example. If I was have to find the current, since from the formula I know that M is equal to Z IT. Let's assume I was asked to find the current. I'll just make that current as the subject, divide by ZT, divide by ZT. So if this cancels this, then I can have the current to be M over ZT. So please, you have to take note of that. That's what matters in the first law. You just make any one of the parameters you have to find as the subject of the formula using the same approach. So Faraday's second law, that one related to the mole, to the charge of electrons, is very, very, very important. Faraday's second law, that one is very, very important to know the charges of each element. So in case if you missed that video, we have already talked about how to identify the charges of an element, either being a metallic element or non-metallic element. So in that case, I will just give, there are many ways of solving it, but there is the simplest way I will use. And so therefore, the second law, there's something that you need to master on. 1 Faraday constant is 96,500 coulomb. I will give you the simple logic of that. So any element dimensions, you have to know the charges of that element. But let me list out the common element that they only give here. They can give you aluminium. Aluminium is +3. They can give copper. They can give zinc. They can give us chlorine. They can give us AU or AG or zinc. Okay, I mentioned zinc. They can give us mercury. They can give us silver, AG. So these are the common ones that we can give. The most common. They can have another one too, but this one, they are very common. You have to know the charges of the element you are trying to solve the problem. Let's say, for example, if I take a case of aluminum, for example, aluminum is +3. That means I'll firstly write out the formula first. That's aluminum 3 plus, it has 3 electron plus 3 electron minus, then to produce aluminum. Is it clear? So there are many ways of formulating the formulas. Let me give the simplest one. Faraday produce the molar mass YIT, which is Q, the IT that we put here, it means Q. YIT produce the mass. You see, this is one of the most simplest formula that we can use to solve electrolysis. Second Faraday, second laws of electrolysis. The N that we put here means the charges of the element that we have here. The number of electrons. If it is 3, then we multiply by 3. If it is 2, we multiply by 2. Now, produce the molar mass. The molar mass of that particular element we are trying to solve the problem. Q produce IT, but we know from what we did earlier from the first law, we know Q is equal to IT, which is a current multiplied by time, then produce mass. So with these formulas, I can be able to solve questions related to Faraday's second law of electrolysis. So it's just so simple and straightforward. Let's take a look at some problem. Let's take a look at some problem from here. Okay, let's look at this. I'll be taking it gradually by gradually so that you can have a better understanding on that. Question says, Calculate question 1. Calculate the current that must be passed into a solution of aluminum salt for 1 hour 30 minutes. In order to deposit 1.5 gram of aluminum, given that molar mass of aluminum is 27 and 1 farad is 96,500 coulomb. So let's look at this problem and see how we are going to approach that. So they said calculate the current. That means we are looking for I, right? So solution, I'm looking for I that must be passed into solution of aluminum. So that means the element we are given there is aluminum. You know, as I told you, aluminum can give out 3 electrons. Now let's see for a first example. They said calculate the current that must be passed into solutions of aluminum salt for 1 hour 30 minutes in order to deposit 1.5 gram of aluminum. So the first thing to be considered, let's first write out the data. So I'm looking for the current. Current is what we are looking for. So that will be passed into solution of aluminum salt for 1 hour 30 minutes. So our time. So given time to be 1 hour 30 minutes. You know, I told you if the time is in this, we have to convert it to seconds. So the thing we are going to do here, you can see the time is in hours. At the same time, we also have it in minutes, but nothing to worry about. We'll convert the 1 in hours to seconds. We'll convert the 1 in minute to seconds as well. So here we have time is equal to the 1 for the hours. That's 1 times 3,600. Then the 1 for the minute, 30 multiplied by 60. You know, 60 seconds make 1 minute. Make 1 minute. Then 3,600 make 1 hour. So here I can have total time to be 3,600 plus 0, 0. This one is going to be 1,800. So by adding the two together, we are going to have 5,400 seconds. So those are total time. So they now said, in order to deposit 1.5 gram of aluminum, so meaning the mass of that aluminum is 1.5 grams. So from the problem, we are given the molar mass of aluminum to be 27. At the same time, we have 1 farad to be 96,500. So now aluminum, now you can see aluminum is at 3 plus, as I mentioned earlier. So that's going to be aluminum 3 plus 3 electron minus give aluminum. So that means here aluminum can be 3 because it can give 3 electrons. So go back to the formula. It's that n farad produce molar mass, IT produce mass. So now our n from there is 3. That means that we have 3 multiplied by 1 Faraday is 96,500. Produce molar mass of aluminum we have there is 27. Then high is what I'm looking for. Time, our time. What is our time? Our time is 5,400. Produce mass. The mass that we have is 1.5. So the next thing is to make our high at the subject of formula. So how are we going to do that? Just make a simple cross multiply. So meaning what we have here, we multiply this one. At the same time, what we have here, we multiply this one. So if I do that, that means that we have I multiplied by 5,400 multiplied by 27 is equal to, so this times this, that is that we have 3 multiplied by 96,500 multiplied by 1.5. So in making this at the subject, making high at the subject, divide both sides by 5,400 multiplied by 27. 5,400 multiplied by 27. So here, if I do that, 3 multiplied by 26,500 multiplied by 1.5 divided by 5,400 multiplied by 27. So if I do that, the result is going to be 2.98 by approximations ampere. You can see that. So the one you have to find, you just have to make it as a subject of the formula. So let's see another problem. Let's look at another problem. Let's see another question. Question 2. This one says that 0.222 gram of divalent metal is deposited when a current of 0.45 ampere is passed through a solution of its salt for 25 minutes. Calculate the relative, or calculate the molar mass of the metal given that 1 Faraday is 96,500 coulomb. You see these questions, what do we need to do? Because from the problem itself, we are given the name of the element is not given, but they said it is a divalent metal. So how are we going to go with that? It's simple and straightforward. You don't need to worry. So they say 0.22 gram of divalent metal. So it's metal. So what do we need to do? We are given the mass to be 0.222 gram, and it's divalent. You know, the divalent is what? Yeah, it's 2 divalent. So if I want to write that, let's say the metal is M, that's going to be M2 plus 2 electrons to give M. It's deposited when a current of 0.45 ampere. So meaning our I is equal to 0.45 ampere. It's passed through a solution of its source for 25 minutes. You know, I told you if the time is in minutes, we have to convert it to seconds. So we are given time to be 25 minutes. So they now say calculate the molar mass of the metal. So meaning I'm looking for the value of molar mass of the metal. So let's convert this one. Let's convert that one because the value of the time we have there is in minutes. We have to convert it to seconds. So if I multiply, okay, which one? So time is in minutes. I can just multiply this by 60. If I do that, I will have the time to be 1,500 seconds. Can you see that? So now going back to the formula, Farad produce molar mass, high T produce mass. So our N, since it's divalent, our N is 2. We have 2 multiplied by our Farad, 1 Faraday constant is 96,500. Molar mass of that element is what we are looking for. Then our I is 0.45. Our time is 1,500. Give mass, and our mass we're given from the problem, we say is 0.222. So here I cross multiply I want to make my mass as the subject so that this one will multiply this and this one will multiply this. So meaning that we have 0.45 multiplied by 1500 times mm is equal to, so what we have here and what we have here is that 2 multiplied by 96,500 multiplied by 0.22. So what do we do? This multiply this, at the same time this also multiply this. So since I'm looking for m, I will make my m as the subject of the formula, divide all through by 0.45 times 1500 is 0.45 times 1500. So molar mass is equal to, so let's divide this. 2 multiplied by 96,500 multiplied by 0.222 divided by 0.45 multiplied by 1500. So if I do that, what I have here is 63.5 by approximation. Which makes 63.5, I think that one goes to be copper. Because there's some problem that you can say, can you guess the element? So we have the molar mass of that element to be 63.5. So that's what we have for the Faraday first law and 5 second law. So just make sure that you know how to make use of the formulas. If you know how to make use of the formulas, either the first law, either the second law, you'll be able to use the formula. So thanks for watching. So please don't forget to like our videos, share, subscribe so that others too can be able to benefit. So thanks for watching.